Hello, everybody. I'm Ludovico. I work in the data management organization. I will talk to you about how to modify the data reduction cascade in an ESO reflex workflow by including your own scripts, your own external routines in terms of Python scripts. This example is focused on Python scripts, but you can use shell scripts or through Python, you can call any other software, for example, IDL or C++. Okay, the first question is, do you hear me loud and clear?
Yes, we do.
And do you see my mouse moving through the screen?
Yes.
Okay, good. Everything I will describe you today is summarized in this document here, for which I put the link. And this document contains further examples and instruction on how you can include Python scripts into your workflow. ESO Reflex is designed to execute pipeline recipes to reduce the data. And together with a given pipeline, we distribute the so-called workflow that is that contains a predefined data reduction chain. This data reduction chain is, let's say, flexible somehow. So as Sabine and Wolfram just explained you, is flexible in the sense that you can select recipe parameters. Sometimes you can even decide your own data reduction strategy. You can trigger some recipes instead of others and so forth. But also, Reflex allows you to modify a given workflow. So it is possible to modify this predefined chain by adding your own routines, your own external routines. As I was mentioning before, the most convenient way for doing so is by including Python scripts. So let's say that you have a Python script that does a very nice cosmic ray cleaning or very nice source detection or a very nice sky subtraction, better than what the pipeline does. I mean, you can plug it into the Reflex workflow and use that instead. Or as additional processing step to what the workflow already does. Python actors actually are already included in many workflows. I mean, you have seen the interactive plots from Sabine's talk that are present in the majority of the workflows. I mean, those are written in Python. There are workflows that we distribute, for example, the Muse Zap workflow that is designed to to do a better sky subtraction cleaning on Muse exposures. It runs recipes written in Python. Giraffe workflows allows you to do cosmic array cleaning with other Python tools. So the inclusion of Python scripts, actor recipes is already something that is in place since some time. So what do you need in order to modify the data reduction cascade by including your own script? You just need a little knowledge of Python. I mean, beginner level is more than enough. I mean, I'm less than a beginner and I'm able to do that. You need, of course, a Python script that you would like to plug into the workflow. You need to have the software you would like to run, Python 2 or 3 installed in your system, and all the required modules to run your Python script. If your Python script wants AstroPy, you need to have AstroPy in your system, and nothing more. As I was telling before, we have a document that provides you instructions and examples. If you are eager to know more advanced example, you can have a look at John Pritchard's presentations from 2018, and I'm putting here the link. You can find it on the net. The Python actor. So the Python actor is a component in Reflex that is designed to execute Python scripts. So this is what you have to plug in into your workflow in order to be able to use a Python script. I will show you how it works exactly in few minutes, because I'm planning to do a live demonstration about that. Now, how do you write a Python script that can be plugged into an ESO reflex workflow? So the algorithm you need to execute needs to be plugged into an interface that communicates between the algorithm and the reflex itself. In the figure on the right, I'm summarizing the 3 areas that this script has to do. Okay, first area is obvious. You need all the import statement you would like, that you need. Then area 2 is the algorithm itself. Can be anything, something that your supervisor gave you, something you find on the net. It's the algorithm you would like to introduce, and this algorithm need to be plugged into an interface. This interface has 3 parts. One part that defines the inputs and the output ports, which is responsible to getting the files from previous actors in Reflex and giving those files to the algorithm. Then let's say the customized part, which is the only thing you have to care about, that simply tells how to run the algorithm, on which file to run the algorithm. And the last part simply takes the output of the algorithm and give it back to Reflex so it can be processed by other actors. These 2 parts, P1 and P3, are basically identical for all the algorithms. The only thing you need to write in the interface is this second part, the customized part, that instructs all the scripts how to execute the algorithm. This might look complicated, but it's actually very, very simple. Let's have a look on how a typical Python script looks like. So I'm showing here the interface. Let's concentrate on the central part only, the one highlighted, let's say, in black. This is the customized part. It's very simple. It's the only thing you have to write. For example, this part can be very simple. And in this example, I simply do a loop on the input files. If the file category is, let's say, a science, I do something, I execute my script. If not, I simply broadcast the output as this is without doing anything. So this is just a loop that tells how to run my algorithm, my script. If I have a science file, then I run my script. Otherwise, I move on. Here, this is the real part of everything. This is what calls my script. As I said before, can be anything: sky subtraction, cosmic ray cleaning, a kind of image processing, can be anything. The other 2 parts are basically copy-paste. You don't have to worry about it. They just need to be present in your script. Basically, the first part simply defines the input and the output ports of your actor to get the fits files and then to broadcast the products. And here is just you simply broadcast the products here. As I said, you don't have to worry about the first 2 parts. The only thing you need to concentrate is a few lines that tells the script, that tells the Python script how to call your algorithm. And this call here simply is connected to the real algorithm. That can be anything. In this example, I simply take the data and divide it by 2, but can be anything. And I will show you a more sophisticated example later on. So I will show you now a practical example on how to plug a Python script into a reflex workflow. And for the example, I will include cosmic ray cleaning on force 2 reduced spectra, two-dimensional spectra. So let me close this for a moment. In the meantime, do you have questions?
There are none so far.
Okay, good. Okay, I'm trying to find, okay. Okay. So as Sabine showed you before, if I type my ESO reflex, oops, if I type my ESO reflex command -L, I have the list of all the available workflows that I have installed in my system. I want to run the example on the force spectroscopic workflow, so I just have to type either the full path name of the workflow, just the nickname here. And I'm launching the spectroscopic workflow. As I mentioned in the beginning, this example is concentrated on Python, but through Python you can launch anything. Executables, shell scripts, IDL scripts, and R programs, no problems. This is loading. Few seconds. Okay, here you have again the force spectroscopic workflow. Let me adjust the zooming. Okay, in my case, I have already set up the directories so that they are pointing to the locations that I have the data. So I will not spend more time on the upper part here because Sabine already explained you how it works. I will simply show again a feature here that is inspect the previously reduced data. So I double click on it. I'm asked inspect previously reduced data. The default is no. Now I want it to yes. Commit. Animate at runtime. Okay, and then play. Now I'm prompted up directly with the Product Explorer because I wanted to inspect previously reduced data. So this is what was done before. This is my data set. I have only one execution of this data set. And the description, I can see that default parameters were used for the reduction of this data set. So I want to inspect the results. Let's say this file here. I can inspect it in two ways. I can, let's say, oops, sorry. I can directly display the pipeline results. If I click here in the menu, display pipeline results, and I get the interactive window of reflex that showed in previous executions the result. I can see here, okay, I have the spectrum. Here I see the source. The sky is more or less nicely subtracted except for this line here. But I do see a lot of cosmic rays and I don't like it. Let's say that I would like to exploit another software, not the one provided by the pipeline, another software to remove the cosmic rays. So at this very stage, the workflow as it is does not allow me to do it, but I can plug an external software to my workflow. So let's close this window. I continue. Then I'm asked, do you want to continue with data reduction? No, because I don't want to use this workflow. I would like to plug in my own routine, my own algorithm for cosmic ray cleaning. So I have a routine in Python, which is called PyCosmic. It's installed in my system, and I want to plug it in into the workflow. So on the left side, I look here. I have the possibility to inspect all the various components that I can plug into Reflex. So I type Python, and I select this one here, the so-called Python actor that has a little blue dot on the bottom here. And I simply take it and drag it into the workflow. You see now that my workflow has a new component, the Python actor. Now, this actor itself does not know what to do because it is not linked to any software. So I have to instruct this Python actor to run my script. How do I do it? Very simple. I double click on it, or I select configure actor. And then here on the first line of the window that pops up, I can specify the Python script I would like to execute. The most difficult part in this entire process is to remember where you have saved your script. So talks, okay. Okay, I have this script here that I select, and I am linking this Python actor to this script. Now, before proceeding, let's have a look how the script looks like. This is the script. And basically, the main part here is what I was previously describing as interface. What you see here is the interface of the script. The part that I'm lighting is the first part that is responsible just for creating the ports. You don't have to worry about it, just copy paste from one script to the other. The last part here is, again, nothing you have to worry about, just copy paste from another script to another. Here, central part, I simply do a loop on the files that are arriving into the actor through the port. I decide to run the cosmic ray cleaning only on this specific category. And then I'm simply calling my script. This do stuff. This is the call to the real algorithm, which is up here. Okay, I just have 3 lines that are calling PyCosmic with certain parameters, but this can be as long as you want. I mean, as complex as your algorithm is. So, okay, let's go back to the window of the Python configuration. As I said before, you simply have to give the location of the Python script you would like to execute. You can, let's say, activate the lazy mode. As for the recipes, you can rerun it many times. If you run it with the same parameters, it does not redo the job, but simply keeps record and reuse the previous executions. You can specify what to do in case of failure. So I will set it to the default, which is recipe failure mode, which is specified at the very beginning of the main workflow canvas. And then I press commit. Now you see that the Python actor now has 2 extra elements, the input soft and output soft. This is because I have put these instructions here in my script. These lines that I simply copy paste from an example already told the script, the Python actor, to create 2 ports. In this port here, input fits file will arrive, and the port here, products will be broadcasted. Now it's time. Now I have connected the Python actor to my script. Now it's time to connect the Python actor to the rest of the workflow. So I wanted to do the cosmic ray cleaning after the science recipe, but in principle, I can plug it whenever I want. So I simply edit the relation here, click on it, move, tuck, tuck. Now the Python actor that runs the cosmic ray cleaning is connected to the workflow. I have a brand new workflow that does something more than what I got from the pipeline installation. So I can press play. Again, I am prompted with the Product Explorer. These I already saw before, so I can continue. I'm asked, do you want to continue with the data reduction? Yes, because now I have customized the workflow the way I want. Yes, go on. I have the data set. I'm prompted with the list of data sets. This was already explained by Sabine before. What I want to do is I want to reprocess the data that were already reduced before, which is this data set here was already reduced. You see the OK here. Review the description. This was done with default parameters. Now I want to do a new reduction with my cosmic ray cleaning routine. Okay, now I continue. So everything will be the same as before. Lazy mode will trigger again and show the previous results. I don't want to see this window anymore, so I will disable the window in subsequent runs. Continue. Okay. Now I have another window. I don't want to see it again. So continue. Now I have the same science recipe, some science results as before. You see a lot of cosmic ray. Now if I press continue, those products will be broadcasted to my Python actor that will execute the extra cosmic ray cleaning. It will take a few seconds. Just be patient. It's taking long before I did not do this before. So it's a new execution. Was not done before, so it takes time to do it. All the other steps were previously done, so the lazy mode was triggered. So any questions in the meantime?
Not that I can see any in the chat. Okay. Yeah. There's one coming. Okay. Where can we find such scripts with part 1 and part 3?
Okay, let me resume back my presentation. If you go in here, this link here, you will find a manual with the tutorial, the examples, and the links to the examples that contain this part 1, part 2, part 3.
Okay.
Just follow this link.
And there's another question now. Mm-hmm. If a new task, for example, cosmic ray cleaning, is added in the ESO reflex, I suppose the default similar task has to be deactivated. Is that true? And how do we do that?
You mean if you don't want to run the cosmic ray cleaning? I mean, you simply, well.
No, I think if someone wants to replace a current reflex procedure by your own procedure. Let's assume.
Okay, let's say okay. Now I see what you mean. There is an example in the document how to include Python scripts. An example that shows you how to use another, for example, another algorithm instead of the master bias creation. So the example will show you to execute your own routine for master bias creation instead of the one provided by the force pipeline. So there is an example that does it. Basically, let me press continue. The work has been done. Basically, you go in here. Let's say you open the actor of the recipe you would like to replace. In this case, the bias, well, can be anything. You get rid of it, you press the delete button, and then you include your own Python actor, and you link it to the script you would like to execute. Be aware that if you replace a recipe, the output must be compatible with the pipeline, in the sense that if the product is used in other recipes, the other recipes, the product needs to be compatible with the other recipes. For example, if the other recipes expects a master bias to be an image, then you have to produce an image, not a table. That's what I want to say.
But okay. This is true also for putting your own script somewhere else, right? I mean,
yes. In my case, I'm putting the script at the very end, so I don't really care about the output format. But yes, if you produce an output, that output, if used, must be compatible with the software that is using it. So now let me inspect what I've done. So if I press play, I again see the product explorer. I see my data set, 2 executions. The one with the default parameters, I can, let's say, where is it? This one, say, inspect with sci soft b ds9. This is my original product. Now let's have a look what has been done by the inclusion of this external routine. Say map new. This is what I have generated. If I inspect it, oops, sorry. Inspect with ds9. Okay. Scale. You see that the cosmic rays are gone. So, summary, Reflex allows you to include external routines. The best way for doing that is via the Python actor. With Python, you can call anything, Python scripts, shell scripts, IDL scripts, C scripts, whatever you want. To include your own script is very easy. You just have to be sure that you embed it into an interface, which is written in Python. The interface is very simple, consists in 2 parts that you simply copy paste from previous examples, and the only thing you have to code is the way your script is called. For example, if you want to run it on the science frames, what's so-called science, you have to write science. If you want to call it bias, you have to run it on biases. Depends on the category of files that you would like to process. If you don't put anything here, will be run on all the input frames. So no problems. Let's suppose that you are happy now. with your new workflow. You would like to use it for your own PhD thesis. You would like to save it. So as Sabina was mentioning, the most convenient way for saving it is through export as XML. Forget about this warning, doesn't really matter. You decide the name, Cosmic Ray Cleaning, and you save it. Then, when you call your ESO reflex script, where is it? Oops, sorry, wrong button. ESO reflex minus L. Okay, you see it. Your force spectroscopic cosmic ray cleaning. And you can launch it, as Sabine showed you before. And I'm stopping here, and I take questions.
Thanks very much, Ludo. We have one more question here. And if your Python script depends on other input parameters from the workflow?
There is an example in the document how to do that. This is a little bit more complicated, but not that much. In the sense that you can, okay, let me bring back the script. Everything I'm saying is well explained in the tutorial. So you simply have to add another port here that accepts, let's say, instead of the set of files, it can accept a set of parameters. So you will have an extra port onto which you give the parameters to your script. And the parameters has to be written in a kind of reflex way. And you have the example here in the tutorial. Let just me find the place and view, zoom. Okay, zoom here. Basically, you define the parameter this way. Again, there is a lot of copy paste. Simply have the name of the parameter, the original value, and you can put the parameter. You can define the, if you do it this way, you can define the parameter on your workflow. You add the two parameters here, very simple. Let me do it live. Okay, cancel. This is let's say parameter, my recipe parameter, change the name, my recipe parameter. I just created a parameter. If I add this part here into the workflow, I can give the value here, say 5, whatever 5 means, and then the Python actor will accept 5 as a recipe parameter. All the steps are explained in this tutorial.
Many thanks for that. Are there any other questions for Ludo? Doesn't look like.
There's a question in the Reflex Pipeline questions channel.
Oh, okay. From Joanna, Thomas Osip, how does Reflex handle bad pixel masking and error propagation?
Pixel masking and error propagation are done by the recipes. Reflex is an interface to run recipes. As long as recipes does it, reflex called the recipe, and that's done by the recipe.
Does this answer the question in principle, or? And the recipes are, of course, explained. I mean, the content of the recipes are, of course, explained in the pipeline manuals, correct?
Yes, yes, that's right.
Okay. Good. Yes. Thanks.